Step outside on a clear night, far from any city, and look up. Let your eyes adjust to the darkness for 20 minutes, and then look up again. The sky you see is the same sky that every human being who has ever lived has looked up at. The same stars that were there when the first anatomically modern humans lived in East Africa 300,000 years ago are there tonight. The same Milky Way that arched overhead when the first cities were built in Mesopotamia and Egypt is arching overhead right now. The same brilliant point of Sirius that rose with the Nile floods in ancient Egypt is rising tonight. The night sky is the most ancient shared human experience. The number of stars visible to the naked eye from anywhere on Earth under ideal dark sky conditions is approximately 9,096. This is the total of stars bright enough to be detected by the human eye under perfect conditions. From any single location, you can see about half of the celestial sphere at any one time, which means the maximum number of stars visible from one location on one night is roughly 4,500. In practice, stars near the horizon are dimmed by the additional atmosphere they shine through, and very faint stars near the limit of visibility are difficult to detect except when looking slightly off to the side, using the more sensitive peripheral rod cells of the retina rather than the less sensitive cone cells at the center. A good observer under excellent conditions might count 2,000 to 3,000 stars in a single night. Tonight, the night sky is outside. The drone beneath these words is as low and constant as the universe itself. Breathe slowly and let the sky come to you. The Bortle scale, developed by amateur astronomer John Bortle in 2001, is a 9-point scale that measures the darkness of the night sky from any given location. A Bortle 9 sky is the sky of an inner city. Only the moon, the planets, and perhaps 20 or 30 of the brightest stars are visible, and the zodiacal light and the Milky Way are invisible. A Bortle 1 sky is the darkest sky measurable, found only in the most remote locations on Earth, deserts and high-altitude plains far from any human settlement. Under a Bortle 1 sky, the Milky Way is so bright it casts faint shadows. The zodiacal light is immediately visible and extends in a faint pyramid from the horizon to the zenith on either side of the sky. The Gegenschein, a faint oval of light directly opposite the sun, is easily visible. The air is full of stars in every direction, and the sky between the bright stars is itself luminous with the combined light of thousands of stars too faint to be individually resolved. The Milky Way, as seen from Earth, is the combined light of the stars in the disk of our galaxy that are too faint and numerous to be individually distinguished. It appears as a broad, irregular band of soft light stretching across the entire sky from horizon to horizon, rich with structure, brighter, more concentrated regions, and darker gaps where dust clouds and the spiral arms block the background starlight. The broad dark lane that divides the brightest part of the Milky Way near the center of the galaxy is called the Great Rift, and it is not a gap in the stars, but a dense band of interstellar dust clouds in the foreground that obscures the brilliant star fields of the galactic center behind it. The Great Rift extends from Cygnus in the north through Aquila and Serpens into Sagittarius and Scorpius in the south. The center of the Milky Way, the region toward which the constellation Sagittarius points, is approximately 26. 00 light years away, and is hidden behind 20 to 30 magnitudes of extinction from intervening dust clouds, and visible at optical wavelengths, but revealed in radio, infrared, and X-ray. The star field near Sagittarius, even at optical wavelengths, where the most distant stars are obscured, is among the most densely populated visible parts of the Milky Way. And on a dark night, the rich star clouds of Sagittarius are one of the most beautiful sights in the sky. The stars of the night sky are not all the same. They differ in brightness, in color, and in the quality of their light. The brightness of a star as seen from Earth is measured on the magnitude scale, a historical system derived from the ancient Greek astronomer Hipparchus, who ranked stars in 6 categories, from first magnitude for the brightest to 6th magnitude for the faintest visible to the naked eye. The modern magnitude scale has been made precise and extended in both directions. The very brightest stars have negative magnitudes, and objects visible only in telescopes have large positive magnitudes. Sirius, the brightest star in the night sky, has a magnitude of -1.46. The star Vega, which serves as the calibration standard for the modern magnitude scale, has a magnitude of 0.03. The faintest stars visible to the naked eye under good conditions have magnitudes of about 6.5. The color of a star tells you its surface temperature. This relationship, known as Wien's displacement law, states that the peak wavelength of the radiation emitted by a blackbody is inversely proportional to its temperature. Hotter objects emit more blue light, cooler objects emit more red light. The hottest stars, O-type stars, with surface temperatures above 30,000 Kelvin, appear distinctly blue-white. The Sun, with a surface temperature of about 5,778 Kelvin, appears pale yellow. The coolest stars visible to the naked eye, M-type red giants and supergiants, appear distinctly orange-red. With a little practice and attention, the color differences between stars are clearly visible to the naked eye. Sirius, in the constellation Canis Major, is the brightest star in the night sky and appears brilliant white with a faint blue tint, indicating a surface temperature of about 9,940 Kelvin, significantly hotter than the Sun. Its brilliance is partly intrinsic. It is about 25 times more luminous than the Sun, and partly a consequence of its proximity. It is one of the nearest stars to Earth at a distance of only 8.6 light years. Vega, in the constellation Lyra, is the 5th brightest star in the night sky and has a distinctly blue-white color with a surface temperature of about 9,600 Kelvin. It served as the northern pole star approximately 12,000 years ago due to the precession of Earth's rotation axis, and will serve as the pole star again in about 14,000 years. Arcturus, in the constellation Bootes, is the brightest star in the northern celestial hemisphere and the 4th brightest in the entire sky. It has a distinctly orange-yellow color, indicating a surface temperature of about 4,286 Kelvin, lower than the Sun's. Arcturus is a red giant, a star that has exhausted the hydrogen in its core and expanded to about 25 times the Sun's diameter. It is also notable for its high proper motion across the sky. It is moving at about 122 kilometers per second relative to the Sun, and will move noticeably across the sky on a timescale of tens of thousands of years. In about 500,000 years, Arcturus will have moved so far from its current position that it will no longer be a prominent naked eye star. Antares, the heart of the scorpion in the constellation Scorpius, is one of the most visibly red stars in the night sky, its name meaning rival of Ares, the Greek god of war, because its ruddy color rivals that of Mars. Antares is a red supergiant with a surface temperature of only about 3,500 Kelvin and a diameter about 700 times that of the Sun. If Antares were placed at the center of our solar system, its surface would extend to approximately the orbit of Mars. It is one of the most massive stars visible to the naked eye and is expected to explode as a supernova within the next 100,000 years or so. When it does, it will be visible in daylight and will be bright enough to cast shadows at night, a spectacle that will last for weeks or months. Let your breathing slow. The stars are all ages. Some are billions of years old, much older than the Sun. Some are millions of years old, brilliant and brief. They are at vastly different distances, and the light from each star that reaches your eye tonight left that star at a different time. The light from Sirius left 8.6 years ago. The light from Arcturus left 37 years ago. The light from the Pleiades left 440 years ago. The light from Deneb and Cygnus left approximately 2,600 years ago. The night sky is a layered exposure of time, different depths of history arriving simultaneously at your retina. The constellations are one of humanity's oldest intellectual achievements, the organization of the apparent chaos of thousands of stars into recognizable patterns, each associated with a story or a season or a navigational reference. The 88 officially recognized constellations, standardized by the International Astronomical Union in 1922 and 1930, cover the entire celestial sphere with defined boundaries, though the shapes and stories associated with the brightest stars in each region vary enormously from culture to culture. Orion is perhaps the most universally recognized constellation, visible from every inhabited part of the Earth and prominent enough in both hemispheres that virtually every culture that has ever existed has recognized it. The three stars of Orion's belt, Alnitak, Alnilam, and Mintaka, are among the most recognizable alignments in the sky, equally spaced and of similar brightness, striking in their linearity. Cultures around the world have seen them as three kings, three sisters, three fishermen, a string of pearls, and countless other images. In ancient Egypt, the three belt stars were associated with the god Osiris, and their rising and setting on the horizon influenced the orientation of certain monuments. Betelgeuse, marking Orion's right shoulder, is one of the most studied stars in the sky because it is a red supergiant similar in evolutionary stage to Antares and is expected to go supernova in the cosmologically near future. In late 2019 and early 2020, Betelgeuse dramatically dimmed to its faintest level in recorded history, generating speculation that it might be about to explode. The dimming was subsequently attributed to a large mass ejection from the star's surface that cooled and condensed into dust, temporarily obscuring part of the star's light. Betelgeuse recovered its normal brightness by mid-2020 and continues to vary irregularly, as is typical for red supergiants. The Scorpius-Orion antipathy is a feature of the sky that has been noted since ancient times. Orion and Scorpius are on opposite sides of the celestial sphere, and one rises as the other sets, so they are never visible simultaneously from mid-latitudes. The Greek myth that explains this arrangement has the hunter Orion and the scorpion Scorpius placed on opposite sides of the sky by the gods so that they cannot continue their conflict. The Pleiades, a tight cluster of stars in the constellation Taurus, are among the most culturally significant stars in the history of astronomy. Visible to the naked eye as a fuzzy patch containing anywhere from 6 to 9 individual stars, depending on visual acuity and sky conditions, the Pleiades are actually a cluster of approximately 1,000 stars at a distance of about 444 light-years, gravitationally bound and moving together through space. The brightest members are hot blue-white B-type stars with ages of about 100 million years, young by stellar standards. The Pleiades appear in the mythology, folklore, and astronomical tradition of cultures on every continent. In Greek mythology, they are the 7 sisters, daughters of Atlas and the ocean nymph Pleione, placed in the sky by Zeus after Atlas was condemned to hold up the sky. The Pleiades are referenced in the works of Homer, Hesiod, and the Old Testament. In Japan, the Pleiades are called Subaru, and the 6-star logo of the Subaru Automobile Company is a direct representation of them. In Australian Aboriginal tradition, the Pleiades are associated with women and with stories that vary by cultural group, but are remarkably consistent in identifying the cluster as female. In Native American traditions of the Lakota people, the Pleiades are the Taurus constellation and are associated with the story of the origins of Devil's Tower in Wyoming. The universality of the Pleiades in human mythology is a testament to the cluster's distinctive appearance, small enough to be seen as a unit, large enough to contain clearly multiple stars, at exactly the right declination to be visible from virtually every inhabited latitude. The pole star, Polaris, marks the north celestial pole to within about 0.7 degrees and appears essentially stationary in the sky while all other stars rotate around it during the night. Polaris is a F-type yellow supergent about 447 light-years away, intrinsically very luminous but appearing only of second magnitude because of its distance. It is not actually the brightest star in its neighborhood of the sky, it is only the north celestial pole star because the precession of Earth's rotational axis, which traces a circle on the celestial sphere with a period of about 26,000 years, has currently brought the pole close to Polaris. In 2000 BC, when the Egyptian pyramids were being built, the pole star was not Polaris but Thuban in the constellation Draco. In 14,000 AD, the brilliant star Vega will serve as the pole star. The circumpolar stars are those that, from a given latitude, never set below the horizon. From 50 degrees north latitude, for instance, all stars within 50 degrees of the north celestial pole are circumpolar. They trace circles around Polaris and remain above the horizon throughout the night and throughout the year. The constellation Ursa Major, the Great Bear, which contains the familiar pattern of 7 stars known in North America as the Big Dipper and in Britain as the Plough, is circumpolar from most of the continental United States and Europe. Cassiopeia, the W-shaped queen, is also circumpolar from these latitudes, and on clear nights it can be observed to circle Polaris opposite the Big Dipper, rising in the northeast as the Dipper descends in the northwest. The celestial sphere is the conceptual framework used to describe the positions of stars and other celestial objects. It is an imaginary sphere of infinite radius centered on the observer or on the Earth's center, on which all celestial objects appear projected. The positions of stars on the celestial sphere are described by two coordinates, right ascension, which corresponds to longitude on Earth and is measured in hours and minutes and seconds from 0 to 24 hours, and declination, which corresponds to latitude and is measured in degrees from the celestial equator, with 0 degrees at the equator and plus 90 degrees at the north celestial pole. This system, like all coordinate systems, is arbitrary, but it has the immense practical utility of allowing the positions of celestial objects to be recorded and communicated with precision. The seasonal change of the night sky is produced by Earth's annual orbit around the Sun. As the Earth moves through its orbit over the course of a year, different parts of the celestial sphere become visible in the evening sky as others disappear into the twilight on the other side of the Sun. The constellation Orion dominates the winter evenings in the northern hemisphere because, in winter, Earth's night-side hemisphere is facing in the direction of Orion, while in summer, the night side is facing away from Orion, which then rises and sets with the sun and is invisible. The summer sky in the northern hemisphere is dominated by the summer triangle, formed by the bright stars Vega and Lyra, Deneb and Cygnus, and Altair and Aquila, which ride high overhead on summer evenings and are associated with warm nights and clear skies. The planets visible to the naked eye, Mercury, Venus, Mars, Jupiter, and Saturn, were known in antiquity as wanderers from the Greek planets because they move against the background of the fixed stars in ways that the other stars do not. This wandering motion is the result of the planets orbiting the Sun at different speeds and at different distances, so their apparent positions against the background stars change from night to night and week to week. The wandering of the planets was a source of fascination and puzzlement for ancient astronomers. The planets obeyed rules, completing their paths against the stars in regular periods, but occasionally moved backward and retrograde against the general direction of their motion, a phenomenon that the geocentric models of the universe required complex and unwieldy mechanical explanations to account for. Venus is the most brilliant natural object in the night sky other than the moon, sometimes bright enough to cast faint shadows on a very dark night. It appears either as an evening star setting in the west after sunset, or as a morning star rising in the east before sunrise, never appearing far from the sun in the sky because its orbit is inside Earth's. The Mayans tracked Venus with extraordinary precision, knowing its synodic period of 583.92 days to within a fraction of a day, and correlating its appearances as morning and evening star with their ritual calendar. Several Mayan codices contain detailed Venus almanacs. Jupiter is the second brightest planet and the most consistently bright, always near magnitude -2 or brighter, and always cream white in color, never twinkling like a star. Stars twinkle because they are point sources of light whose light is significantly disturbed by turbulence in the atmosphere. Planets, which appear as tiny disks rather than points even to the naked eye, average out the atmospheric turbulence across their disk and appear steadier. On excellent nights, Experienced naked-eye observers can detect that Jupiter is not a point, but a very small disk, and Galileo's observation of its moons in 1610 with a small telescope transformed the understanding of the solar system. Mars, when near opposition, can rival Jupiter in brightness, and has a distinctly reddish color that makes it unmistakable. Ancient observatories are proof that the study of the night sky is not a modern pursuit, but one of the most ancient human activities. Stonehenge, constructed in multiple phases from about 3000 BC to about 1500 BC on Salisbury Plain in England, has long been associated with astronomical alignments. The heel stone, standing outside the main circle, aligns with the midsummer sunrise when viewed from the center of the monument. The orientation of the main axis is also precisely aligned with the midwinter sunset. Whether Stonehenge was primarily an astronomical calendar, a religious site, or a monument to ancestors remains debated, but its astronomical alignments are real and intentional. The Göschek Circle in Germany, constructed around 4900 BC, is one of the oldest known solar observatories. It consists of a circular enclosure with gates aligned with the sunrise and sunset at the winter solstice. Nabta Playa in the Egyptian Sahara, a site dated to around 5000 BC, contains stone circles and megalithic structures aligned with the rising of the midsummer sun and possibly with certain bright stars. These sites, predating writing by millennia, demonstrate that the observation and recording of astronomical phenomena were among the earliest and most persistent human intellectual activities. Tycho Brahe, the 16th century Danish astronomer, achieved extraordinary precision in naked-eye astronomical measurement using large, carefully calibrated instruments of his own design. Working before the invention of the telescope, from his observatory on the island of Afen in the Razun Strait, Brahe measured the positions of stars and planets with an accuracy of about 0.5 arc minutes, limited by the sharpness of the human eye rather than by the quality of his instruments. His comprehensive catalog of 777 stars, later extended to 1,000, was the most accurate ever compiled to that point, and his meticulous observations of the planet Mars provided the data from which Johannes Kepler derived his 3 laws of planetary motion, which in turn provided the observational foundation for Newton's law of universal gravitation. Meteor showers are among the most spectacular events visible to the naked-eye observer of the night sky. They occur when Earth passes through a stream of debris left in the orbit of a comet, with individual particles most smaller than a grain of sand, entering the upper atmosphere at high speed and burning up from friction, producing brief streaks of light. The Perseid meteor shower, which peaks each year around August 11 to 13, is the most reliably spectacular of the annual showers, producing 50 to 100 meteors per hour at its peak under dark skies. It is caused by debris from Comet Swift-Tuttle, which last passed close to the Sun in 1992 and will return in 2126. The Leonid meteor shower, which peaks around November 17 to 18, is normally a modest shower of about 15 meteors per hour, but at intervals of about 33 years, when Earth passes close to the densest part of the debris trail from its parent comet, Tempel-Tuttle, the Leonids produce meteor storms with thousands of meteors per hour. The Leonid storm of 1833 produced an estimated 100,000 meteors per hour at its peak, an event that is described in historical accounts as appearing as if the sky was raining fire. This event is credited with inspiring the scientific study of meteor showers. Before 1833, the periodic nature of meteor showers and their association with cometary debris was not understood. The Geminid meteor shower, which peaks around December 13 to 14, is exceptional because its parent body is not a comet, but the asteroid 3200 Phaethon, which may be a dead or dormant comet. The Geminids are the most prolific annual meteor shower, with rates of up to 120 meteors per hour under ideal conditions, and they produce a high proportion of bright, slow, colorful meteors. Unlike most other showers, the Geminids are visible throughout the night because the radiant point, the constellation Gemini, is above the horizon by early evening in December. The aurora borealis, the northern lights, is the most spectacular atmospheric light show visible to naked eye observers in the higher latitudes. It is produced when charged particles from the sun, carried by the solar wind or ejected in coronal mass ejections, are guided by Earth's magnetic field toward the polar regions and collide with atoms and molecules in the upper atmosphere at altitudes of 100 to 300 kilometers. The collisions excite the atmospheric molecules, and when the excited molecules return to their ground state, they emit light at specific wavelengths. The characteristic green color of most auroras comes from the excited oxygen atom at altitudes of about 100 to 150 kilometers. Higher altitude oxygen produces red auroras. Nitrogen produces blue and purple colors. Active aurora can fill the entire sky with shifting curtains, rays, and bands of colored light, moving with a grace and otherworldliness that makes it one of the most overwhelming visual experiences available to human beings. The physicist who first understood the physics of the aurora in detail, Christian Birkeland, at the turn of the 20th century, built vacuum chambers and magnetic models and bombarded them with electron beams to reproduce the aurora in his laboratory, demonstrating that it was caused by charged particles from the sun interacting with Earth's magnetic field decades before the physics of the solar wind was fully understood. The zodiacal light is a faint pyramidal glow extending from the horizon along the plane of the ecliptic, caused by sunlight scattered by the cloud of interplanetary dust in the plane of the solar system. It is visible in the west after astronomical twilight in the spring, and in the east before dawn in the autumn in the northern hemisphere, and it requires extremely dark skies to see clearly. Its brightness can rival or exceed the background Milky Way in very dark locations. The Gegenschein, a faint, roughly oval patch of light visible at the point in the sky exactly opposite the sun, is a related phenomenon, sunlight backscattered from the same interplanetary dust cloud toward the observer. Noctilucent clouds are the highest clouds in Earth's atmosphere, forming at altitudes of about 76 to 85 kilometers in the mesosphere during summer at high latitudes. Unlike ordinary tropospheric clouds, which are hidden by the shadow of the Earth at night, noctilucent clouds are high enough to be illuminated by the sun after it has set and before it has risen, glowing with a distinctive electric blue or silver color in the deep twilight sky. They were first recorded in the years after the 1883 eruption of Krakatoa and were initially thought to be caused by volcanic material in the upper atmosphere. Modern research has shown they are composed of ice crystals forming on meteoric dust at the extreme cold of the mesosphere during polar summer. The naked eye double star Mizar and Alcor in the handle of the Big Dipper is one of the most tested optical tests of the night sky. The two stars appear separated by about 12 arc minutes, well within the resolution of good naked eyes, and have been used throughout history as a test of vision. Mizar itself is a true binary star, the first binary star system to be recognized as such through telescopic observation in 1650. Subsequent studies have shown that Mizar A is itself a spectroscopic binary, Mizar B is a spectroscopic binary, and even Alcor has a companion, making the entire system at least 6 stars bound by gravity. The variable star Algol in the constellation Perseus was the first eclipsing binary star to be identified. It dims from magnitude 2.1 to magnitude 3.4 and back every 2 days, 20 hours, and 49 minutes, a variation that was noted by the Arabic astronomer Al-Ghul in the medieval period, and that gives Algol its name, meaning the demon star or the ghoul, presumably because its changing brightness appeared demonic. The variability was first explained scientifically by the English astronomer John Goodricke in 1783, who correctly proposed that the dimming was caused by a fainter companion star periodically passing in front of the brighter one. Goodricke was deaf from infancy, worked in what must have been extraordinary isolation from the mainstream of scientific discourse of his time, and died of pneumonia at the age of 21, 4 days after being elected a Fellow of the Royal Society for his work on variable stars. The Andromeda Galaxy, M31, is the most distant object visible to the naked eye at a distance of approximately 2.537 million light-years. Under excellent dark sky conditions, it appears as a small, elongated fuzzy patch of light near the Great Square of Pegasus, extending about 3 degrees across the sky, 6 times the diameter of the full moon. Most of what you see of M31 with the naked eye is the bright central bulge of the galaxy. The full extent of M31's disk, as revealed in long exposure photographs, covers about 200 square degrees of sky, nearly 400 times the area of the full moon. The light entering your eye from the Andromeda Galaxy tonight left that galaxy approximately 2.537 million years ago, before the genus Homo existed on Earth. Let your body be completely still. The light from Andromeda that you might see tonight is 2.537 million years old. It left a galaxy containing hundreds of billions of stars, crossed 537 million light years of intergalactic space, entered our atmosphere, was focused by your eye, and registered on your retina. The entire history of the human species fits in that light's travel time. The entire evolution of intelligence on this planet is contained in the time since that light left its source. From southern latitudes, 2 additional galaxies are visible to the naked eye: the large and small Magellanic Clouds, satellite galaxies of the Milky Way at distances of about 160,000 and 200,000 light-years respectively. They appear as detached patches of the Milky Way, since Europeans would not see them until Ferdinand Magellan's circumnavigation in the early 16th century, and they bear his name in Western astronomy. In fact, these galaxies have been known to the indigenous peoples of the Southern Hemisphere for tens of thousands of years, and their appearances in different Aboriginal, Polynesian and African astronomical traditions are varied and rich. The night sky looks different from different latitudes. From the equator, the entire celestial sphere is accessible over the course of a year, with every star rising and setting. From the North Pole, the entire northern celestial hemisphere is permanently above the horizon, circumpolar in the most extreme sense, while the entire southern hemisphere is never visible. The stars of the southern sky, Canopus, Alpha Centauri, the Southern Cross, the Magellanic Clouds, are essentially invisible from Europe and most of North America, as foreign to a northern observer as the stars of the northern sky are to someone in the southern hemisphere. The night sky, properly seen, is not background decoration. It is a library. It contains the physics of stellar evolution in the colors and brightness variations of the stars. It contains the history of the solar system and the motions of the planets. It contains evidence for the formation of the moon and the craters visible through binoculars. It contains evidence for the structure of the Milky Way and the distribution of star clouds and dark lanes. It contains a direct window on the past and the light that arrives each night from different depths of time. And it contains, in the form of the Andromeda Galaxy, a direct view of another system of hundreds of billions of stars, the largest structure visible to the unassisted human eye. Let your thoughts be as open and unhurried as the sky itself. The stars are doing nothing to demand your attention. They shine because that is their nature, because nuclear fusion in their cores releases energy that radiates outward through their surfaces and into the universe for hundreds of light years in every direction, some small fraction of which reaches your small planet and your small eye. They are not performing for you. They are simply what they are, and they have been what they are for millions or billions of years before any human eye existed to see them. Tonight, you are connected to every person who has ever looked up at the same sky. The shepherds of ancient Mesopotamia who first named the constellations, the Polynesian navigators who sailed the Pacific by the stars, the architects of Stonehenge who aligned their stones with the midsummer sunrise, the Arab astronomers who catalogued and named most of the bright stars in the modern sky, the indigenous Australians who told stories about the dark patches in the Milky Way as well as the bright stars, the navigators of the age of exploration who used Polaris and the Southern Cross to cross oceans, and every human being before them and every culture on every continent who lay down in the darkness after a long day and looked up. The Arabic star names that label most of the bright stars in the modern sky are a legacy of the Islamic Golden Age of astronomy from the 8th to the 15th centuries, when Arab astronomers not only preserved and translated the Greek astronomical tradition, but extended it, adding new star positions, correcting old errors, and constructing instruments of unprecedented precision. Names like Aldebaran from Aldebaran, the follower following the Pleiades across the sky, Rigel from Ral al-Jawza, the left leg of the giant, Deneb from Danab al-Dajaja, the tail of the hen, Fomalhaut from Fam al-Hut, the mouth of the fish, Algol from Al-Ghul, the demon. These names are still in universal use, spoken every night by astronomers and stargazers in every part of the world, a linguistic monument to the scholars of the Islamic world that has persisted for 1,000 years. The systematic naming of stars was formalized by the German astronomer Johann Bayer in his star Atlas Uranometria, published in 1603, which assigned Greek letters to the stars in each constellation in roughly decreasing order of brightness. Alpha Centauri is the brightest star in Centaurus, Beta Canis Majoris, the second brightest in the Great Dog, and so on. This Bayer designation system is still in standard use for stars that do not have proper names. The English astronomer John Flamsteed, working in the late 17th and early 18th centuries, assigned numbers to stars within each constellation in order of right ascension, producing the Flamsteed numbers that provide a second systematic naming scheme for fainter stars not covered by Bayer. In 2016, the International Astronomical Union formally standardized 336 proper star names selected from names in use across multiple astronomical traditions, providing official designations for the most important and historically significant bright stars. The Hyades are the nearest open star cluster to the Sun at a distance of about 153 light-years, and they form the face of the bull in the constellation Taurus. The V-shaped pattern of the Hyades surrounding the orange giant Aldebaran is one of the most distinctive naked-eye clusters in the sky, though Aldebaran itself is not physically part of the cluster, but lies in the foreground at about half the Hyades' distance. The Hyades contain about 200 stars gravitationally bound together, with the brightest members being orange and red giants that were once similar to the Sun but have evolved off the main sequence. The distance to the Hyades was one of the first steps on the cosmic distance ladder, established with precise parallax measurements. From the Hyades' distance, the luminosities of their type of star were calibrated, and these calibrations were then applied to similar stars and more distant clusters to extend the distance scale. The Great Orion Nebula, M42, is the nearest large star-forming region to Earth, at a distance of about 1,344 light-years. On a dark night, it is faintly visible to the naked eye as a fuzzy star at the center of the three stars that form Orion's sword, hanging below his belt. In binoculars, it becomes a distinct, elongated nebula. In a small telescope, the glowing green-gray wisps of ionized gas surrounding the four young, hot, trapezium stars at its heart are clearly visible. The nebula is a vast cloud of hydrogen gas, approximately 24 light-years across, heated and ionized by the radiation of the newly formed massive stars at its center. New stars are forming within it right now, embedded deep in the molecular cloud from which the trapezium cluster recently emerged. The Coal Sack is a dark nebula in the constellation Crux, the Southern Cross, visible from southern latitudes as a notable dark void in the Milky Way, a region where interstellar dust blocks the light from the billions of stars behind it. To naked-eye observers in the southern hemisphere, the Coal Sack is one of the most striking features of the Milky Way, a genuine patch of darkness standing out against the rich star clouds of the southern Milky Way. Australian Aboriginal cultures have recognized the Coal Sack and other dark nebulae in the Milky Way as figures in their own right. The Aboriginal constellation, known as the Emu in the Sky, is defined not by bright stars, but by the dark nebulae of the Milky Way, including the Coal Sack as the head of the Emu, with the dark lanes of the Great Rift forming the body and legs stretching toward Scorpius. The variable star Mira in the constellation Cetus is the prototype long-period variable star, a class of pulsating red giant stars that change in brightness by factors of hundreds over periods of months to years. Mira varies from as bright as magnitude 2, easily visible to the naked eye, to as faint as magnitude 10, visible only in a telescope over a period of about 332 days. This variation was first noted by the Dutch astronomer David Fabricius in 1596, who initially thought he had discovered a new star. When it faded and then reappeared, it was recognized as a genuinely variable star and was named Mira, meaning wonderful or astonishing, by Johannes Hevelius in 1662. Mira is now known to be a red giant star about 11 times the mass of the Sun near the end of its life, pulsating in size and luminosity over its 332-day period. Light pollution has transformed the human relationship with the night sky. In 1994, after a major earthquake in Los Angeles caused widespread power outages, the Griffith Observatory received calls from residents concerned about a strange silvery cloud in the sky. The cloud was the Milky Way, visible to city residents for the first time in years, or perhaps in their lives. This episode illustrates how completely artificial lighting has severed the visual connection between modern urban humanity and the natural night sky. Studies estimate that 99% of people in the United States and Europe live under skies so bright that the Milky Way is invisible, and about 1/3 of the world's population cannot see the Milky Way from their home. The International Dark Sky Association, founded in 1988, has worked to designate international dark sky parks, places, and reserves where lighting is controlled to preserve darkness for astronomical observation, wildlife, and human experience. Designated international dark sky parks now number in the hundreds, located in national parks and remote reserves on every continent. Cherry Springs State Park in Pennsylvania, Galloway Forest Park in Scotland, and the Atacama Desert in Chile, home to the world's greatest concentration of professional telescopes, are among the darkest accessible locations in the northern and southern hemispheres, respectively. The human visual system is exquisitely adapted to the dark sky that has been the constant companion of our species for most of its evolutionary history. The dark adapted eye achieves its maximum sensitivity after about 30 to 40 minutes in complete darkness, during which the rod cells of the retina replenish their supply of rhodopsin, the visual pigment that is bleached by light. In the fully dark adapted state, the human eye can detect individual photons. The threshold for light detection has been measured at between 5 and 14 photons absorbed by the retina within a small region within a short time. This extraordinary sensitivity is the product of millions of years of evolution under unpolluted night skies, and it remains fully functional in every human being, latent and waiting for the darkness that would allow it to express itself. The twinkling of stars, technically called scintillation, is caused by the refraction of starlight by pockets of air at different temperatures in Earth's atmosphere, which bend the light by slightly varying amounts as they move. A star, effectively a point source of light, has its entire image shifted by each pocket of turbulence, causing the star's apparent position and brightness to fluctuate rapidly. The amount of twinkling is a rough measure of atmospheric stability. What astronomers call seeing, poor seeing produces rapid twinkling and blurs telescopic images, while excellent seeing produces steady, non-twinkling stars and sharp telescopic images. The site selection for major telescope observatories is a years-long process that includes extensive measurement of the seeing quality to find locations where the atmosphere is most stable. The Sagittarius star cloud, the densest and most visually spectacular part of the Milky Way visible to the naked eye, sits in the direction of the galactic center and contains some of the most ancient stars in the Milky Way. The light from the Sagittarius star cloud has been traveling for approximately 26,000 years to reach us, a reminder that even the most familiar parts of the naked eye sky represent distances and timescales that dwarf human history. Within the Sagittarius star cloud, the density of stars is so high that if Earth orbited a star within this region, the night sky would be ablaze with thousands of stars brighter than Sirius appears from our current location. Vincent van Gogh's Starry Night, painted in June 1889 from the window of his room at the St. Paul de Montceau Asylum in St. Hermie-de-Provence, depicts the night sky over the village with a swirling, visceral energy that captures something true about the experience of looking at a dark, star-filled sky. Art historians and astronomers have worked together to identify the stars depicted in the painting, finding that the bright star at upper right may be Venus, and the crescent moon and the relative positions of other features are consistent with the sky as it appeared over St. Army in the early hours of June 19, 1889, the painting's turbulent. Living sky represents something that every person who has spent time under a truly dark sky recognizes. The night sky is not static and cold, but dynamic and overwhelming, a field of ancient light that seems almost alive in its complexity and depth. The night sky asks nothing of you. It simply offers what it has always offered, an accurate and beautiful report on the state of the universe around you, in the form of ancient light arriving at the speed of 299,792 kilometers per second from distances ranging from a few light years to a few million light years, all of it arriving simultaneously, all of it present right now. The nearest star system to the Sun, Alpha Centauri, is a triple system at a distance of 4.24 to 4.37 light years. The two main stars, Alpha Centauri A and B, are a visual binary orbiting each other with a period of about 80 years. The fainter third star, Proxima Centauri, is a red dwarf that is currently the physically nearest star to the Sun. From the southern hemisphere, Alpha Centauri appears to the naked eye as a single brilliant star of magnitude -0.27, the third brightest star in the sky, easily distinguishable by its warm, slightly yellowish tint compared to the cooler nearby star, Beta Centauri. The light entering your eye from Alpha Centauri tonight left that system 4.24 to 4.37 years ago. It is the freshest starlight you can receive from a star other than the Sun. Barnard's star, a red dwarf in the constellation Ophiuchus, at a distance of 5.96 light years, has the highest proper motion of any star in the sky. It moves across the celestial sphere at a rate of 10.36 arcseconds per year, completing the equivalent of the apparent diameter of the full moon in about 180 years. Proper motion, the actual motion of a star across the line of sight, reflects the true velocity of the star through space relative to the Sun. Barnard's star is approaching the Sun and will reach its closest point, about 3.75 light years away, in about 9,800 years. at which point it will be the nearest star to our solar system. Over long timescales, the constellations are not fixed. The familiar patterns of Orion and the Big Dipper will be unrecognizable in 100,000 years, as the proper motions of their individual stars carry them to new positions. The double cluster in Perseus, NGC 869 and NGC 884, is a spectacular pair of open clusters visible to the naked eye as a hazy double patch between Perseus and Cassiopeia. Both clusters are at distances of about 7 to 7,500 light years and contain hundreds of stars each, including many luminous blue and red supergiants. In binoculars or a small telescope, the double cluster is one of the finest objects in the northern sky, a rich field of stars with a striking concentration at the centers of each cluster. On a dark night, the naked eye appearance of the double cluster as a misty brightening of the Milky Way is itself one of the more remarkable things a careful observer can find. The globular cluster Omega Centauri, NGC 5139, is the most massive and largest of the Milky Way's approximately 150 known globular clusters, containing roughly 10 million stars packed into a spherical region about 150 light-years across at a distance of approximately 17,090 light-years. From southern latitudes, it is visible to the naked eye as a fuzzy star of magnitude 3.9, larger in apparent diameter than the full moon, though much fainter. In binoculars, it resolves into a glowing ball of innumerable stars, and even in a small telescope, the central regions show individual stars. Omega Centauri may be the stripped core of a dwarf galaxy that merged with the Milky Way in the distant past, retaining its own stellar population of extreme age. With some stars estimated to be 12 billion years old, among the oldest stars in the universe. The globular cluster M13 in Hercules, sometimes called the Great Globular Cluster in Hercules, is the most impressive globular visible from northern latitudes, containing about 300,000 stars in a sphere about 145 light-years across at a distance of 22,200 light-years. On a dark night, it is just barely visible to the naked eye as a faint fuzzy patch, and in binoculars it becomes a clear circular glow. In 1974, the Arecibo telescope broadcast the Arecibo message in the direction of M13, a 1679-bit binary message encoding information about human life and the structure of Na. The message will take 22,200 years to arrive, and any reply would take another 200 years to return. The entire exchange, if it happens, will occupy 44,400 years of cosmic time. The Pacific Islander navigators, who sailed the Pacific Ocean for thousands of years, crossing thousands of kilometers of open ocean without instruments, used the stars as their primary navigation tool. They had memorized the rising and setting points of hundreds of stars on the horizon over the course of the year, and could use any visible star to determine direction. They knew the altitude of stars in the sky at specific latitudes and used this as a latitude finder. They tracked the motion of stars through the night to maintain a consistent heading. The Hawaiian word for navigator is Aklea, which means star of gladness, and it is also the Hawaiian name for the star Arcturus, which rises due east and sets due west and passes directly overhead at the latitude of Hawaii, making it one of the most important navigational stars for Pacific Islanders approaching the islands. The twilight sequence that bookends every night is a gradual transition governed by the geometry of Earth's shadow. Civil twilight begins and ends when the sun is 6 degrees below the horizon. During civil twilight, ordinary activities can be performed without artificial light. Nautical twilight begins and ends when the sun is 12 degrees below the horizon during nautical twilight. The horizon is visible at sea, but the sky is dark enough for navigational stars to be seen. Astronomical twilight begins and ends when the sun is 18 degrees below the horizon. After astronomical twilight ends, the sky is fully dark and all astronomical observations can proceed without interference from the sun. The sequence from sunset to astronomical darkness takes between about 60 and 90 minutes depending on the latitude and the time of year, and this gradual darkening reveals the stars in order of their brightness, the brightest appearing first in the twilight, the faintest appearing last as the sky reaches full darkness. Sleeping and stargazing share a quality that is difficult to name but immediately recognizable when experienced. Both require a slowing of attention, a willingness to let the mind drift from one detail to another without insisting on resolution or conclusion. Both are most accessible when the body is still and the surroundings are quiet, and both lead to a state in which ordinary daily concerns become less insistent, less urgent, replaced by an awareness of something larger and more patient. The night sky is perhaps the most effective meditation object that the universe provides, infinite in extent, indifferent to your particular anxieties, populated with objects of extraordinary variety and beauty, and available for free to anyone willing to go outside and look up. Breathe slowly. The drone is low and constant. The stars are out there above the roof above you, turning slowly through the night as the earth rotates beneath them, or as they appear to rotate around the pole, the same motion that has carried the stars across the sky since long before there was anyone to watch. The light from Sirius that enters the room around your curtains left that star 8.6 years ago. The light from the Pleiades that falls on your roof tonight left the Pleiades in 1581. The light from Deneb above you left that star approximately when the Roman Empire was at its height. All of this ancient light is falling on you on this particular evening, on this particular part of a small planet orbiting an unremarkable star in the outer disk of a typical spiral galaxy. They will still be doing this when you wake. They will be doing it for billions of years to come. Good night. Rest in the ancient light of the sky.